Hello everyone. PLC is an electronic device designed specifically for industrial applications which can achieve powerful digital operation control and control various types of machinery or production processes through digital or analog inputs and outputs. This class mainly focuses on the structure and working principles of PLC. Programmable controller architecture. There are various types of PLC, and their functions and instruction systems are also different, but their structure and working principles are similar. Their structure is usually composed of 6 main parts: CPU, memory, input interface, output interface, communication interface, and power supply, as shown in Figure 1. CPU is the central processing unit. ROM system program memory, RAM user program and data memory. The input interface receives control signals such as push buttons, position switches, proximity switches, master command controllers, and other signals. Output interface is the result of CPU processing through the amplifier circuit to drive output devices, such as contactors, solenoid valves, signal lamps, analog, and other signals. Communication interface mainly connects the programmer, touchscreen, computer, and other devices, etc. Power supply for the CPU, memory, input interface, output interface, and other internal electronic circuits work. Configured DC switching regulated power supply usually also provides DC power for input devices. The CPU, also known as the central processing unit, is the core of the PLC used to read input variable, complete various operations specified by user instructions, send the results to the output end, and respond to external devices. 2. Memory. The system program memory mainly stores system management and monitoring programs, as well as programs that compile and process user programs. It is fixed by the manufacturer and cannot be changed by users. User programs and data storage mainly store user-generated application programs, various temporary data, and intermediate results. Input interface. As shown in Figure 2, the input interface receives control signals such as buttons, position switches, proximity switches, master control, and other signals using optoelectronic coupling circuits to reduce electromagnetic interference and improve reliability. There are 3 types: switch quantity, analog quantity, and digital quantity. Output interface. As shown in Figure 3, the output interface drives output devices such as contactors, solenoid valves, indicator lights, etc. through the power amplifier circuit based on the results processed by the CPU. 5. Communication interface. The communication interface mainly connects programmers, touchscreens, computers, and other devices. 6. Power supply. A DC switch-regulated power supply configured for internal electronic circuits such as CPU, memory, input interface, output interface, etc., usually also provides DC power for input devices. Performs internal processing in the run state. Performs communication services. Performs input processing. Performs program execution. Executes output processing. If you are in the stop state, only internal processing and communication services are executed. The working principle of programmable controllers. Programmable controllers have 2 basic operating states: run-stop, namely the run state, and the stop stat in the running state. The programmable controller achieves control functions by executing user programs that reflect control requirements in order to make the output of the programmable controller respond to input signals that may change at any time in a timely manner. The user program is not only executed once but repeatedly executed until the programmable controller stops or switches to the stop working state. In addition to executing user programs, the programmable controller also needs to complete internal processing, communication processing, and other tasks during each cycle. Each cycle can be divided into 5 stages, as shown in Figure 4. During the internal processing in the run state, perform internal processing, check if the CPU and internal hardware of the module are functioning properly, reset the monitoring timer, and complete other internal tasks. In the communication service stage, execute communication services, communicate with other intelligent devices, respond to commands typed by the programmer, and update the display content of the programmer. In the input processing stage, input processing is performed, reading the on or off states of all external input circuits into the input image register. During the program execution phase, when executing the program and running the user program, even if the state of the external input signal changes, the state of the input image register will not change accordingly. In the output processing stage, the output processing is executed and the CPU transfers the on-off status of the output image register to the output latch. Stop if in the stop state only internal processing and communication services are executed. Finally, let's take some exercise. That's all, thank you.